Okay, in order to solve this system of linear equations, I need to take each equation and I need to put it in slope-intercept form. Slope-intercept form means I need to get y by itself. So I'm going to take this first equation, 2x plus 3y equals 6, and I'm going to subtract 2x on both sides. That's going to give me 3y equals 6 minus 2x. And I'm going to divide both sides by 3. And what that's going to do is it's going to give me y equals 2 minus 2/3 x. So when I look at this, I can identify what the slope is. And the slope from this equation is negative 2/3. It's what x is being multiplied by. I needed to make sure that I have the negative sign because there is a negative sign in front of the 2/3. And then I also need to identify the y-intercept. That is 2. So now I have the slope and the y-intercept of the first equation. I'm going to take the second equation, 2x minus y equals negative 2. And I'm going to subtract 2x on both sides, just like I did in the first equation. And I'm going to end up with negative y equals negative 2x minus 2. As long as I have the negative sign with both, it's fine. What I have to remember is that when I'm doing this, that there is a negative 1 there. So I need to divide both sides by a negative 1, and everything gets divided by a negative 1. So I end up with y equals 2x plus 2. So now when I identify my slope, I look at what x is being multiplied by, that's 2, and my y-intercept is equal to 2 also. So when I look at this, I see that this right here is being multiplied by x, so this is my slope, while right here, this is my y-intercept. It doesn't have a variable. So now in order to graph these, what I need to do is I am going to plot the y-intercept for the very first equation, 2x plus 3y equals 6. So when I plot that, I'm going to take and I'm going to put a point when the when the y-intercept is 2, so on the y-axis. And then from that point, when I look at this fraction, it says negative 2/3. That negative sign is only with one of the numbers. So what I could do is I could do down 1, 2, and be at the origin, and then move over 1, 2, 3 to the right. Or I could start back here and do 1, 2 up and 1, 2, 3 to the left. So when I do that, I get this ordered pair. And I can keep going 1, 2 up, 1, 2, 3 to the left, or I can start with this point and I can do 1, 2 down, 1, 2, 3 to the right. Now, I should be using a ruler. Unlike Notability, this isn't going to make a line that is that great. As you can see, I'm using that did not come out very well. But you get the idea that it really should be a straight line. I'm going to get rid of some of this extra right here. And the line continues on. Now I'm going to take, and now I'm going to graph the second equation, 2x minus y equals negative 2. So when I look here, I need to plot 2 for the y-intercept. So I'm going to do that. It's going to be right here. And the slope says 2 also. Well, that's the same thing as if I write it as 2 over 1. And so what that's telling me to do is start right here at the y-intercept, and I'm going to go up 2 and right 1, up 2, right 1. Or I could go down 2, left 1, down 2, left 1. So I could do either, I'm going to do both, up 2, right 1, up 2, right 1, or I'm going to start back at the y-intercept and I'm going to do down 2, left 1, down 2, left 1. So from here now, I am going to draw my line, and again, I don't have a nice straight edge, but you get the idea. And the point where they intersect, which happens to be right here, so the solution to this system of equations will be 0, 2. And that's what you're finding when you're solving a system of linear equations. You're finding the point where they intersect.